So hope you can see on the screen. This is car price assignment. This is a data set for details of the cars and the price. So you have to predict the price of the car based on the parameters. So there is a lot of parameters here. So it is from the Car Deco website. So you no need to consider all the parameters. If you want, you can consider some of the parameters. Mainly, find the linear relationship between horsepower and price. Just modifies the coding part and then try to find out the relationship between horsepower and price in the data set. So this is linear regression. If you want to include car length, car width, engine size, you can use that also for multiple linear regression. And house prices, similarly, prediction of prices. For prediction of prices, you have so this is your price column based on the square feet living. Okay, so you can use this one. So you can use any of this size to find out the price. So this is another data set. This is also for linear. And one more I have given, that is for classification, logistic regression. You have to find out whether the person get the insurance based on the age, whether the person will take the insurance or not. You need to find out that. So this is your dependent variable and the age is your independent variable. So these are the three data sets we can work on. Support vector mission, SVM. So this is one of the classification algorithm mainly used in the machine learning. So first we need to understand what is machine learning. Machine learning means making your computer to learn and to take the decision. So learning is nothing but training. We are giving training to the computer. That means the computer is learning our data, and based on that, it will take the decision. So we have various algorithms in the machine learning. We can classify that into two. One is regression. Another one is classification. So regression is nothing but a scalar value, predicting the scalar value, continuous price. For example, price, stock market. So the output like that, it has a single output. Predicting the price, predicting the stock market is a single output. And another type of things is there that is called classification. And one more is there that is clustering, grouping. Okay. So now SVM comes under the classification algorithm. Similarly, we have a data set and we are plotting the data set. It is X1 and X2, and the data points are grouped into red dots as well as green dots. Assume that. Okay. So this is your data set. When you plot that, you will have a group like this. So you can easily separate this, isn't it? So you can easily separate with a vertical line, or you can have an horizontal line for that, or you can have a slope line. Okay. And you have various types of lines to classify these 2 points, because these are 2 groups in the data set. So our algorithm classify the data set into 2 groups, isn't it? And we can use these methods. So logistic regression is also a classification method, but it is divided into 2, either 0 or binary output. But in this case, you can have multiple groups also. But usually we will discuss with 2 groups. Okay. So now, what is this SVM means? These 2 points, how the grouping is taking place, how the classification is taking place is based on the maximum margin. Okay. What is this maximum margin? So if you have the data set here, so these 2 points have the maximum margin between this data set. Okay, so you can clearly see this is the margin of this. This point is the margin of this group, and this point is the margin of this group, isn't it? So this is the extreme points of these two data sets, these two groups. So this is called support vectors. What is that SVM? SVM means nothing but support vector machine. Okay. So these 2 points are called as support vectors because these 2 points represents the extreme points of the classification. So our aim is to find out. And in between that, you will have a hyperplane. That is the margin of these two, between these two classifications. We call that as maximum margin. This red point is called as negative hyperplane, and this green point, extreme point, is called as positive hyperplane. The middle one is called maximum margin hyperplane. So this is how your algorithm will classify your data sets. So now we will see that with an illustration. What is special about SVM? Consider these two pictures. So this is an apple and this is an orange. Okay. Now your data set needs to classify apple as one group and orange as one group because your data set has these two. Similarly, as we predict, the SVM calculated the apples as one group because these are similar, and orange as one group because these are similar to each other. So this area, this region is called actual apple parameters. For example, if you take the apple, it is red in color and it is round in shape. Okay, so there are some features, right? So these features are the main features of the apple. So this has some exception. For example, some of the apple may be in green also. Some of the apple may be like orange. So that kind of apple will be nearer to this one. Similarly, here also there will be some extreme points. Imagine that. So this is the actual representation of the orange. So some oranges are orange shape, maybe look like apple also. Okay, so that is how we are taking that. For example, here is one picture. You see, this is an apple, but it looks like a orange, isn't it? Because it is orange in color. So the machine learning may think this as an orange, but the shape is a little bit different. So the data point for this apple may be this point. Okay, it is closer to the orange, isn't it? So actual apples are like this. That is the standard apples, but some exceptional apples point may be there. Okay. And here also some of the orange. For example, you take some of the orange as green. Imagine like that, and that point may be closer to because this may represent like apple. So it may come to this point. So the distance between these 2 points is calculated as this point and this point is calculated as, these 2 points are called as support vectors, and the distance is called maximum margin. Okay. So for example, if you remove all the other data sets, for example, I'm removing all these data points, okay, and I'm removing all these data points. Even if I remove all these data points from this point, this area, and this area also, my algorithm will not change because my algorithm classification is mainly based on these two support vectors. So based on this extreme cases only, I am determining my margin. I'm determining the classification points, isn't it? So if I, for example, if I remove all other points here, anyway, it will not impact my maximum margin because this maximum margin is only depends on these 2 points. This is called support vectors. That's why the algorithm is called support vector machine. Okay, so it is basically the name comes because of these 2 support vectors. Anyway, if you take any data set and trained using the SVM will choose only 2 extreme points. Based on that only, your margin will, the maximum margin will be calculated, or your data will be classify. That's why it is called support vector machine. Classification. SVM is only for classification. So it will do the classification. It will do prediction also. So there is some other cases. So SVM can be used for regression also, based on the kernel. Okay, there is another subject is there. So based on the kernel points, we can use that for the regression also. SVR, we call that as SVR. But mainly SVM we are using for classification. So it performs well for the classification. So this is all about the intuition of SVM. So SVM is basically a support vector machine. The support vector is nothing but the extreme points of the classification. Based on that, your margin line will be plotted. That is the predictor. Okay. It is a simple algorithm, irrespective of huge number of data. For example, your data set may be 1,000, 2,000. There is lots of data points there also. The algorithm will work at high speed because it is basically consider only the 2 points. Other points it will not consider for calculating the classification, isn't it? So that's how the simple algorithm, but it is very effective in classification. There is no mathematical calculations also. So just it will calculate the extreme points, and then based on that, it will calculate the margin. Okay, now we go to the algorithm part. So I'm going to use SVM for classification. So you can use this data set for linear regression, logistic regression also. The credit card data set. So the first step is we need to upload the data set. Before that, to connect your Google Colab with the server. So credit data set. So what is our aim as a data science engineer? What is our aim is we want to create one model to see whether the customer will pay back the loan or not. So we are as a banking sector, as a bank, we are targeting customers, and we need to find out whether the customers can pay back the loan or not. Okay. So for example, based on the income, based on the age, based on the loan is already having, and based on the parameters. So how is paying back the loan is history. Okay. So these are some of the parameters. Based on that, you will have the output. That is your dependent variable, 0 and 1. 1 means the customer pays the loan. 0 means the customer is not paying the loan. Okay. So this is how your data has been data set. So this is the data set available with you. So from this, we are going to create one model, train the model using SVM. After that, we will calculate whether the customer will, new customer, any customer comes with the record age and the low age and the income, and already they are having some loan data, then you can able to find out whether these customers will pay back that loan or not. Okay. So this is the data set. As usual, we have to do pre-processing first. For that, we have to input the libraries. So open the code sheet. NumPy, once again, I'm just moving fast. NumPy is for array, matplotlib is for plotting the graph, and pandas for handling the tables or CSV files. Okay. And next is importing the data set. Already I have imported that. So the name of the data set is credit card, credit data.cv. And you can see what I have done is 1 colon minus 1. So what that it means? So this colon represents all the rows, and this represents, you know that in the data set, it starts from 0, isn't it? If you go to the credit data, it starts from 0. Client ID is 0, income is 1, and the age is 2, and loan is 3, LTI is 4, and finally you have the default, that is output, dependent variable. So what I've done is I no need a client ID because it is just a serial number. I no need this one or any ID. It's not relevant to the output. So I skip this. How I am skipping this? So I started with 1. So when I started with 1, the ilog function will take income column, age column, and it will leave the last column. So that is nothing but default when you put -1. So this is how this part will work. And y equal to dataset.ilog, what it does is it takes all the rows and it takes the last column. -1 is the last column. Okay. So this is how your data has been saved in X and Y. So what is X? Now we can see when you put the X, you can see the array, first 4 columns. Okay. Income of the first person, 2, 3, 4. And if you put Y, open the code sheet, and if you put Y, you can see the default values. So now we have splitted the data set into 2. So dependent variable and independent variable. Next, we're going to split the data into training set and test set. So how many data sets are here? 2000 entries are there. Okay, 2000 customers are there. So I am going to divide that into test set and training set. So when you have more number of data, your model will work more efficiently because it is learning more data. So that is the beauty of AI. So AI do the prediction based on how much learning it has, how much training we are giving to that AI. So that's why in future the AI will be more powerful than today, because day by day the AI algorithm is learning lots of data, isn't it? So 24/7 the training has been going. If you take any AI algorithm, any AI website or chat GPT, it keeps on learning. Day by day it is learning. So that's why it becomes more efficient. Now splitting the data set into training set and test set. There is a code for that. So you can just copy and paste it. So always you can do this for all the machine learning algorithms when you are calculating either classification or regression. So I'm taking 25% of the data for test and remaining 75% for train. Okay, so you can mention any one thing. If you want to mention test train, a train size, then you can 0.75. Random state for study purpose, so that the same data will be taken for testing and as well as for training. If you use this random, if you use any other number 1, 2, or 3, it may take different values. If you use 0, we will be both on the same page. We will have same result. Okay. Next we go for feature scaling. So we need feature scaling because there is lots of variability in the data. If you see the credit data, you can say income is in the thousands and the age is in the tens, and loan is again in the 10,000s, and the LT is in points. So there is lots of variabilities in this data. So this may produce wrong results. So the performance will affect based on this value. So that's why we need to do the feature scaling. So as usual, we are going to use the standard scalar. So if you want to see what is happening in the data, you can just put the X train, Y train value, and you can see. Okay, so this is how the feature scaling will take in place. sklearn pre-processing, standard scalar we are using, and first X train. Xtrain is the training data, and Xtest is the test, 25% of your data set, and this is the 75%. Okay. And what we are doing is we are going to apply the standard scalar for both the training set as well as for test set. And fit transform we are applying. Fit means it is transforming, and Xtrain. So then we will run the code. After that, we are going to train the SVM model. Okay, just we will see the output of Xtrain. So now we can see all the 4 columns of the data set is in the same range. Okay. So that is the aim. After that, we need to train the algorithm with the SVM. So SVM is also from the sklearn.svm import svc. Okay. So support vector classifier. Okay, there is some regression is also there. We can use. The kernel we are choosing is linear. Okay, so if you want to see, there is lots of different types of kernels are there, and similarly the random state we are choosing as 0. Then we are training the classifier with Xtrain and Ytrain. So what that means, training is nothing but now the algorithm learns the data set. So if you want to learn more about SVM, you can go for scikit-learn, sklearn SVM. If you type on the Google, you will have the documentation of this. Okay. So from this, you can see all the details. So what are the kernels available and what is the sources? There's lots of information available there. So you have some examples also. So if you have time, you just go through all those things. So what are the things you can do with SVM? So they'll give all the documentations, and some coding part also will be there. So this is all about that is scikit-learn. So you can see SVM linear. Let's zoom it. So this is how. So you can see now what are the things available. So this is for classification, linear support classification. You have linear support SVR. So that is regression. So you can do both also. And unsupervised learning also we can do. So there is lots of variation. You can choose that algorithm based on your applications. Okay. So this is all about that. And finally, predicting the new results. So once you've done all those things, before predicting, I want to predict the test result. Okay. After that, I will go for prediction. So I want to check out how my model is working based on the test value. Okay. So that is the thing. So why predict classifier dot predict. Predict means it's going to predict, and this is Xtest. Xtest is the test algorithm. Test data set 25% is there now. And then now your model will predict the value for this data. Okay. After that, I am combining the actual. We know the actual value for Xtest. So that is Ytest, and we got the predicted value for this model from the model also. That is Ypredict. So I'm just joining these two, three. Reshape is we are converting row into vector, isn't it? Row into one-dimensional array into two-dimensional array. So you will have length. This length represents the row, and this is one column. Okay, everything in the column. So now if you run this, you can see the two columns. Okay, so the first value is the predicted value, and the second value is the test value. So when the predicted value and the test value is same, then your model is perfect. Okay, So here there is a difference, 0 and 1. So the model is not perfect here. So there is some variation in the prediction as well as, so, but almost other values are, it is predicting perfectly, isn't it? It's very good. Then we can see the accuracy score for this. We want to see the accuracy score and confusion matrix, then we can see that. Okay, so we'll check what is the accuracy of this model. So for that, we have a code template. You can just copy and paste it. Yesterday, we did the same thing. So that's why I'm moving a little bit faster. You can see now, it is a matrix. You want to see more about matrix? You can similarly, you can go for sklearn and matrix. Then you will have the confusion matrix, accuracy, score, etc. And the confusion matrix is between Y test and Y prediction. And you have the print value. You can see now, this is your confusion matrix. So what is confusion matrix? Yesterday I told that. So once again, I'm just explaining that. So confusion matrix is the predicted value and the actual value are same. So when the predicted value is 1 and the actual value is also 1, then it is correct. So this is the correct one. When the predicted value is 1 and the actual value is 0, then it's wrongly predicted in the red zone. And similarly, if the predicted value is 0 and the actual value is positive, it is in the red. So these diagonal green items are predicted correctly and this one is predicted wrong. So from this, we can see from the output, 425 values is predicted correctly and 54 values predicted correctly, but here it's some deviations 11 and 10. Okay, and the accuracy is 95%. It's relatively good, above 95%. And predicting the result. Now, to predict the result, we have to see the code part. So this is the code, we want to take it. And I'm giving the 4 values. You can give any values. Okay. So one is 6615, some income, and this is the age, and this is the loan, already having the loan, and this is the track record, credit points. Okay. That means this customer will pay back the loan, isn't it? 0 means pay back the loan. 1 means is a default. He will not pay. Okay. So that is the output. Credit card data default means he will not pay. And 0 means he will pay back. 1, he will not pay back. So since it represents 0, and that means this customer will pay back the loan. So we can give loan to this customer. So that's how you can create a model for a bank to predict whether the customer will pay the loan or not. So that's all about SVM. We can use the same data set for logistic regression also. So only thing is you need to change this part. Okay, instead of SVM, we have to do we have to give logistic regression, and then you can find out the comparison between the SVM as well as logistic regression also. So that you can do. So that's all about SVM. If you have any doubt, you can ask. So there is lots of application in support vector machine other than classification of data. It will be used for language processing also. They are using support vector machine, and they are using this support vector machines for classification of images also. So there is lots of application over support vector machine. It's a simple algorithm, but very effective because we are not using any mathematical gradient descent like that. So if you take any linear regression or logistic regression, we are finding the we are predicting the values. There is a predicted line that is based on the mathematical operations, but here it doesn't. It takes the extreme points on the data set. Based on that, it will have the predicted line. So that's the simplicity of SVM. Okay, when the data set is very huge, you can go for SVM and it will work perfectly. Okay, so that's all some of the information about SVM.